Welcome back, learners, and let's continue with our lesson. So, we need to take note that when two powers that are equal to each other and they have the same base, then their exponents will also be equal. So, for example, here is that if I have a to the exponent m and that is equal to a to the exponent n, then that means the exponents will be equal. So, because they will have the same base, and what's important is that they need to be equal to each other. So that means that also their exponents will be equal. Let's look at some examples here. So let's answer the following without using a calculator. What we are actually looking for here is the missing number. So we need to know that 1 is equals to 7 to the exponent of something, and we need to find that something. So because we are dealing with an unknown number, in mathematics, when we are dealing with an unknown, we usually represent it using letters. So let's say that our unknown is a letter M. So we know that 1 is equals to 7 to the exponent M. What do you think is supposed to be in the position of M? Let's think about our laws. When is it that a power is equals to 1? Yes, you are correct. We can change that 1 to 7 to the exponent of 0. Why am I using 7? It's because I want them to have the same base. So what do you see with those two powers? I have 7 to the exponent 0, and that is equals to 7 to the exponent m. Because they are equal and they have the same base, then it means that our m is actually equals to 0, and that is the conclusion that we can make from this. Let's look at more examples. We have 81 is equals to 3 to the power of something. Again, we can use any letter to represent what we do not have. So 81 we know is 3 to the exponent 4. They have the same base. What does this mean? It means that n is equals to 4. Let's look at a last example in this matter. We have 1 divided by 32. So we can use any letter to show that we are working with an unknown. We have 1 divided by 32. 1 divided by 32, that is 2 to the exponent of 5. And that is equals to 2 to the exponent of x. But for us to get them to the same base, we are going to need to move this power from the denominator to the numerator. What happens to it? Remember, it will multiply with the number that is there, and the exponent will become negative. So we now have 2 to the exponent negative 5 is equals to 2 to the exponent x. Can you see what's happening there? They have the same base, which means that the exponents are also equal. So let's move on with our lesson. And our next focus is going to be scientific notation. So what is scientific notation? It is a way of writing numbers that are too big or too small to be written clearly in decimal form. For example, 150 million is written as 1,5 multiplied by 10 raised to the exponent 8. So to write a scientific number, it must have the following conditions. It must be a product of two numbers. It must be written in the form of positive or negative a multiplied by 10 to the exponent n, where a is going to be a decimal number and n is going to be an integer. And our last condition is that it must be a decimal that is greater or equals to 1 and smaller than 10. So we are looking at a number that is in the placeholder of the ones, because it is between 1 and 10. It can also be equals to 1. So for example, I have there 6,130,000. And if I want to write it in scientific notation, I'm going to say that is 6,13 multiplied by 10 to the exponent 6. So what happened here? We are looking at 6 million. And that 6 million, it has to now move to the ones position, where it is going to be able to satisfy this last condition, where it is going to be either equal or greater than 1, but smaller than 10, sorry. So what is going to happen here? We are going to look at how many times the 6 is going to shift to the right to get to the ones position. So our 6 is going to shift here, 1, 2, 3, 4, 5, and 6. So it gets to the ones position, and that is where that exponent 6 comes from. It's because it shifted to the right by 6 units. So that means that 6,130,000 is equals to 6,13 multiplied by 10 to the exponent 6. Another example is if I have a very small number. And what is happening here? Remember, our number needs to be equal or greater than 1, but smaller than 10. So we are going to look at the first number that is not a 0, and we need to shift it to the ones position. So it is going to shift to the left. And now this one is going to shift how many positions to the left? 1, 2, 3, 4, 5. And it is going to be in the ones position. So what does that mean? We are going to write it as 1, comma, see the 1 is there in the ones position, comma 2, 3, 4. The 2, 3, 4 are the rest of the numbers that appear there. And it is going to be multiplied by 10 to the negative 5. And we are using a negative exponent because we are moving to the left. So it means that our number is now going to be 1,234 multiplied by 10 to the exponent negative 5. Let's look at this in detail. If we are looking at a bigger number, then we know that our exponent to the base 10 is going to be a positive number. For example, I have there 324 million. Which number needs to shift to the ones position? It is the 3. So what is going to happen there? We are going to shift it 1, 2, 3, 4, 5, 6, 7, 8. And when we are writing our number in scientific notation, it is going to be 3,24. Those are the numbers that come from our number. And we are going to multiply that by 10 to the exponent. How many times did we shift our 3? We shifted it 8 times. And it is going to be a positive 8 because we are shifting to the right. Then our next number, we are going to have 23,000. And which number are we going to shift into the ones position? It is the 2. So we are going to have 2, 3 multiplied by 10. How do we figure out the exponent that is supposed to be there? That is going to be 1, 2, 3, and 4. And that is going to be 2, 3 multiplied by 10 to the exponent 4. So what you need to remember here is that because positive means direction, we are shifting our number to the right. So that is why our exponent is going to be positive, because we are moving to the right. Our next example is when we are dealing with smaller numbers. And when we are dealing with smaller numbers, that means that our exponent to the base 10 is going to be negative. For example, if I have 0,00023, how am I going to present that in in scientific notation? We are going to look at the first number that is not a 0, and we need to shift it to the ones position. So how many spaces is it going to shift? 1, 2, 3, 4. And that is going to be multiplied by 10 to the negative 4, because we shifted 4 spaces, but we shifted 4 spaces to the left. That means that our number is going to be, our exponent is going to be a negative 4. Then we have 0,4, and for us to write that in scientific notation, which number are we shifting? It is the 4. So we are going to have 4. There are no other numbers there with the 4. So we are going to write that as 4. And how many spaces does it shift to the left? It is only 1 space. So that is going to be 4 multiplied by 10 to the exponent negative 1. Why is it negative? It is because we are shifting to the left. So remember, Because we are shifting to the left, left means a negative direction, and that's why our exponent is going to be negative. Let's end our lesson with just these few questions where we are going to have this number, and when we write it in scientific notation, we are looking at the 5. So our answer is going to be 5,678, which are those numbers there. But we need to first figure out if we are going to the left or right. So because we are shifting the 5 to the left, we know that our exponent is going to be negative. That is 1, 2, 3, 4, 5, 6, 7 spaces to the left. Our next example, we are looking at the 8, that is 876,500,000. So we are going to say that is 8,765, and then we are going to multiply that by 10, and we are shifting the 800 million to the right. So we know that our exponent is going to be positive. 1, 2, 3, 4, 5, 6, 7, 8. Those are 8 spaces to the right. And then we have here 0,001. How are we going to shift it? It is going to be 1 multiplied by, 10. And we are shifting that 1, how many spaces to the left? 1, 2, 3. So that is to the exponent -3 because we went to the left. And our last example is going to be 100. And then we are going to shift the 100. So we are going to say 1 multiplied by 10. And we are shifting that 1, how many spaces to the right? 1, 2. Those are 2 spaces to the right. So we are going to say a positive 2. So that is how we write our numbers in scientific notation, and that is it for today's lesson. I hope you enjoyed this lesson as much as I did, and we will see you next time. Goodbye.